Hello and welcome back to Purus Java tutorials. In this session, we are going to cover about the Lambda expression which is implemented in JDK 1.8. So before to 1.8, this functionality was not there. So let's see what is this new functionality. That is the Lambda expression. So here there are some few advantages which we get out of this Lambda expression. So we will cover all these theoretical benefits in our code by doing few of the programs. So let's see the first one, the first advantage, that is it enables the functional programming. So what is the functional programming? Functional programming is where you can treat the functionality as a method argument or code, right? So before to 1.8, we were only taking the class and objects, and based out of that class and objects, we were calling the methods and we were executing those logic. But in JDK 1.8, because of this Lambda expression new functionality added, we can pass a code to a method as an argument. So let me read the other advantages. Function containing the algorithm that can be treated without belonging to any class. Okay, so that means a function, the algorithm, whatever we keep, normally before to JDK 1.8, we were keeping inside the class, inside a method. But in Lambda, we can achieve like this algorithm can be expressed without any, or can be contained without any object or any class. Now the third one is a Lambda expression can be passed around as if it was an object and executed on demand. So this is mostly same as this one. So we can say that if you pass the code as data, and that particular code can be executed on demand. One more advantage is in the programming, you can do it in a lesser number of code. So let's say before to the Lambda expression, we were using some 10 lines of code. In the Lambda expression, it might be like 5 lines of code. So in this Lambda example, what I wanted to achieve is if I pass a number, let's say 7, right? And whether this 7 number is odd or even, I wanted to get, or I wanted to fetch whether this particular number is greater than 10 or not. So this program basically I can write here that, let's write here. So this program checks if the number is odd or even, or is greater than 10 or not. So how I can do this? So first thing is I can create two methods, right? One is, let's say for example, private uh, void check even or odd, and then I can pass the argument like integer number, right? Integer a, and here I can write the logic, or I can have one more method like private void check greater than 10 or not. And here also I will pass integer a and then the logic, right? So instead of doing all these things, what I have done from the starting is I have taken these two behavior into one interface, so that these two behaviors are separated by each other by implementing two classes. So here I have taken each of the logic from these methods and created two class. One is for determining the even and odd, and one more is determining whether that is greater than 10 or not. So basically I have created two classes. One is this one, even odd determiner, and one is greater than 10 determiner. So both are implementing a number determiner interface, which let me go here, which takes an integer argument, and the implementation is here. So basically greater than 10 determiner is just checking whether it is greater than 10 or not, and the even odd determiner checks whether it is even or odd. And slowly this particular program we will take how we can leverage the lambda expression to do this in a shorter code. We don't need to create two classes here, but instead we can have this code in an lambda expression. Let's see how to go on this one. So here this number determiner, I have two types. One is even and odd determiner and one more is greater than 10 determiner. And what I'm passing is I'm just passing what kind of behavior I need, whether I need odd or event to determine, or I need to determine whether it is greater than 10 or not. So basically I'm passing this behavior as an object here. So either this reference variable or this reference variable I can pass it here, and this run determiner is here itself. It's a static method. It takes the object reference variable and do the operation. So based on this number determiner, what kind it is, if it is odd even determiner, then it checks whether this passed number is odd or even. If I have passed, let's say greater than 10 determiner, then it will check whether it is number is greater than 10 or not. So first I have passed odd and even determiner. Let's run it and see what is the output. So here it is printing using method approach print even or odd, using method approach print even or odd ends. So let's go inside this do operation implementation. So here you should click and say control T. So it will show you what are all implementation of this particular interface, number determiner interface. So basically I have passed order in even determiner. So let's go here, even odd determiner. Basically this reference variable I had kept as odd even determiner. I could have renamed as even odd determiner. So let's just rename it to be clearer. Refactor, rename, even odd determiner. Okay, that's fine. So here control T, let's go to even odd determiner, and inside whatever it is there, it is trying to print it here. Okay, now let's go back, alt, and you can say back arrow. Now let's go to again control T and greater than 10 determiner. Again, what is there? Using method approach print greater than 10 or not. So basically when we pass the greater than 10 reference variable here in this number, in this particular example, then we'll get the output. So let's just change this to greater than 10 determiner and run this. So this should give us whether the number passed is greater than 10 or not. So here less than or equal to 10 it is saying, because I have only implemented like this If it is greater than 10, then it will say greater than 10, else it will just say less than or equal to 10. Okay, this is what all is the approach with interface and implementation of those interface. Now let's see this one, the first point, enabled to treat the functionality as an method argument. So what it is telling is, so what if we take this logic directly and pass that code as an argument here. So this is what exactly it is telling, enable to treat the functionality as a method argument or code as data. So this is what is achieving the functional programming. Let's try to do that one so that it will be clearer. Now, how to convert this thing into a lambda based approach. So you should say that this is one of my logic, right? Even an odd determiner. So I have one logic. So let's take this logic, and this is one kind of logic which I want. So this logic you should put into one kind of argument. So let's take both of the logic, right? Even odd and greater than 10 determiner. So now I have the logic and I want to pass this logic here. So is there any data type which can hold this particular logic? Yes. In the JDK 1.8, you can hold this logic as an interface, which we already have. This is called a functional interface. So if an interface has only and only one abstract method, then it is said to be a functional interface. So let's say if we'll add one more method here, do operation xxyy. So this won't become a functional interface because now it has two abstract methods. So to become or eligible to be a functional interface, the interface should have only and only one abstract method. So let's delete this. Now we are clear that what is functional interface. So we can do like this, number determiner. Let's go to Lambda example here, and the number determiner, let's just rename it to even odd determiner. Let's just comment this out so that we can cover this thing. Okay, since we are just converting all this logic to lambda expression, so we are commenting all this. So here we can say even odd determiner equal to, right? So slowly we'll convert all this. We'll just resolve all this compilation error. Now this logic you will see it is a multi-liner logic. So you need to wrap this logic inside curly brace here, and then at the end of the logic one more curly bracket and semicolon, because we are assigning this particular code or behavior into this particular variable which is of type functional interface. Now do the same for this also and put semicolon. Now you are seeing this variable, right? This logic is using a variable, and since we are using this number determiner functional interface, it knows that it takes a integer variable. So what you need to do is you need to say that I have a variable a here, right? And if I'll take a variable a, what is the logic? So now this has become a lambda expression. So The same goes here, parenthesis start, and I take an argument here a. And what is the logic for this method? I have taken this logic or this particular implementation. So these two are different behavior, and the logic are assigned to a variable which is of type functional interface. Now in case of single line logic, you have an option to remove this curly braces or your flower bracket. Now we have two logic, that is kind of function, right? So we can send this function into this run determiner and then do the operation, right? So here the number determiner is of type interface. Now you will see that this code, this particular logic, does not belong to any class. It is just an interface type. So that is what is the second point. Function containing algorithm that can be created without belonging to any class. So this particular logic does not belong to any class. We have just defined it as a type of interface. Now let's just run this. Let's just copy this code and put it here and try to see what is coming the output. So it should give us the output like using method approach, print greater than 10 and all this, right? Based on our logic. Let's run this. See here, the output is same. Just for clarification, let's just try to put here using Lambda approach and just to delete these things. And here also using Lambda approach ends. Print greater than 10 or not, starts, you can say, and using the Lambda approach here and starts and ends. Okay, now let's try to run this again. So we should get the same information here in the console. See here, using Lambda approach, and it is printing whatever we have given in sys out in this particular logic. So let's try to pass even odd determiner here and let's see the output. So here it is printing whether it is an odd or even using the Lambda approach. Now what all we have skipped to do this? We had skipped creating two classes, that is two behaviors. One is the greater than 10 determiner and even odd determiner. Now these two classes are not used, that is why it is in gray in color. See this. This is what is the fourth point. Few lines of code you require to do this. Even this particular solution you could have done in a anonymous inner class method also, but still that requires two anonymous classes to be created. Here we did not require to create any class. That is what is the fourth point. So we are achieving the same functionality by using few lines of code. Now let's come to the third point. A lambda expression can be passed around as if it was an object and executed on demand. This is what exactly here we have done. This lambda expression has been passed to the method, right? These are the lambda expression. So what is the lambda expression? These are the lambda expression what we have kept inside this variable, and this we are passing into this method. That is what this lambda expression is being passed to this run determiner method. Okay, I feel it is clear. Just let me know if you have any doubts. Please write in the comment section. I'll be uploading this particular code into my Git area that is mentioned in the description of this video. Even I had explained about the anonymous inner class in just previous video. I'm giving the link in the description part. You can go through that anonymous class video also. Now let's see a single liner Lambda function. So let me try to create an interface here. Okay, interface, and we'll say one liner Lambda interface. And here I should annotate this with the functional interface. So what is the advantage of giving this annotation? I'll just let you know. So here I have given functional interface, and let's just write public void operation, and this one. So this has become a functional interface because it has only one abstract method. Now let's say if we will not give this functional interface, what will happen, right? Let's try to just comment this, and I'll just say operation 1. Then you will not get any compilation error. So to get a compilation error, to make your code safer so that no other developer can add one more method and it should not break any other code. That is what is the use of this functional interface. It is the annotation which checks at the compile time whether this particular interface has exactly one abstract method or not. So let's just delete this, and let's come here, Lambda example. Let's try to create a Lambda, single one-liner Lambda, which will just try to print a variable. That's it. So let's just go here and create a Lambda expression for this single liner, one liner Lambda interface, one liner operation. Let's say operation equal to. So does it take any argument? You have to check. Does it take any argument? No, it doesn't take any argument. So you can write like this, and then what is the logic we are going to implement? We are trying to just print a variable, right? Or we are just trying to print, let's say hello. System.out.println. I have not used this shortcut. Just say hello, and let's try to run this. How you can run it? One liner dot operation. That's it. So let's try to run this and see. So here at the end you are saying hello. So that means this particular logic is running over here. Now one more thing we can see, that this bracket you can, this particular parenthesis, right? This particular parenthesis you can skip if there is only one argument. So like this you can write. So you can get rid of this parenthesis also. So this is what from this particular session. Thanks for watching this video, and stay tuned for further lessons.